So today we'll be starting with the useful of Z test, usefulness of Z test, and Z test will be using at a five different situation, and those five different situation will try to understand that which kind of test to be utilized when. Once we are clear about this five tests, I think most of the time 40-50% will work out around that only. So before I start about Z test today, if there's any question based on the previous sessions, we can take up that and then we'll go for the Z test. Any questions so far? So let me share you an Excel file. I think this is visible to you. Now we start with a uh, blank file, uh, Excel file. Right? We'll keep a little bit of larger cells for better comprehension. Now the situation will be, now all of you know that there are various kinds of variable. One would be where you can find out the mean, and other variable where you can find out proportion. The example over here will be simple height and weight. Here the example will be gender or the place of residence like this, right? Here other could be weight. So one cell will be this and other will be proportions. Once you have understood this much, two types of variable, the things become so simple that which statistical test you are supposed to use, you will come to know. And there is a various permutation and combination where you which test you apply in AP info that we'll see. But here there could be a situation where you want to compare individual with you want to compare individual with population. Now, when you want to compare individual with the population in terms of mean, suppose there are
Rachel చెప్పండి
50 individuals.
ఇది
Out
ఒకటి
of that one,
వాట్సాప్
any problem, please mute yourself. If you have any question, then you can unmute and ask. Right? So, suppose you have 100 individuals and you are measuring hemoglobin level of the 100 individuals. Out of that, one person is having hemoglobin level 17, other person is having a hemoglobin of 7 gram. Whether this person belong to this group or not, that you cannot say without any other the values. So you need to have mean also and also standard deviation. Then you can find out whether these people belong to the group or not. So in such cases, we are using the test Z test, but in which you can say that Z is equal to observation X minus x bar. So divided by ST, standard deviation. But in this case of proportion, gender or place, comparing one individual with the rest of the individual usually will not happen. And in extreme cases, there is a Poisson distribution. So at present,
Okay.
will not consider this. Someone is speaking, you want to ask something or you are talking in between? So in this case, we will not consider the proportion part of it, comparing individual with a population. So keeping it as dash. Now there will be a situation whereby you want to compare sample with population. Sample with population. In this also, when you want to talk about the population based on a sample, where you are going to use a mean command, for example, based on the mean hemoglobin level of a sample, you want to talk about the population, want to find out population. In this case, sample you want to compare with population. Or you want to find out whether this sample belongs to this population or not. This two way. At that time, you are using Z, in which you will be see the standard of mean, you are going to use it over here. And so you will compare the population mean with the sample mean. This, let's say, is a population mean, and this is a sample mean, and it will divide it by standard error of mean is at this juncture. And when you want to compare the, let's say, you have a sample of a, let's say, Ahmedabad city, you have taken a sample. Based on that, you want to find out whether people have participated in Navratri or not, or how many persons are suffering from fever today. For that, if you want to find out, that means based on sample, you want to talk about the population proportion, Z will be equivalent to population proportion minus sample proportion, and you will divide it by standard error proportion. In another case, you want to compare two population. When you want to compare two population, essentially you are comparing two sample from which the samples which are taken from the population. So when you want to compare two population, Z will be equivalent to, it will be to x1 minus x2, that means mean 1 minus mean 2, divided by standard error of difference between two mean, right? And when you want to compare two populations proportion, for example, in Bangalore city, how many person are suffering from dengue versus in Bombay city, how many people are suffering from the dengue. So we want to compare whether the significant difference or not in suffering from dengue between two cities. In this case, you need to find out Z equal to P1 minus P2 divided by standard error of difference between two proportions. These are the 5 types of Z which we are going to utilize today, and we'll try to understand this. So I will request all of you to at least write down one example where you can use this. So initially, I will give one example, I will calculate that, and then you will also do the same thing for in your own case study. So first, see the individual with the population. I let me say that I have an example where there are 800 students are studying in medical college, and I want to find out their mean exam marks, and that is, let's say it is the 65 marks. Mean score of their marks is 65, and let's say we consider this as a performance in the for time being subject of anatomy. 65 marks they are getting mean, and the standard deviation is, let's say, 10. Suppose this is our data. In this case, if someone asks you a person having marks 90, do you think that this is exceptionally good, extraordinary, yes or no? And other thing, other person getting 45 marks. What do you think? Is it extraordinary less, or it is just within the group? So here we can see two ways. One thing is the 95% covers will between me plus minus the standard deviation. That means 65 plus minus 2 standard deviation, that is 20. So you can say that the range would be 45 to 85. This will be the range in which 95% student will fall. Now here the 45 is almost on the border, we can say that is within the group, while the 90 is exceptionally scoring high. The same way, suppose this is a 49. You can say it is not excel, it is within the group. Now, in terms of Z, when I want to apply Z and tell whether this is comparison between individual with the population, individual student performance, you want to compare with the population of 800 students. When I apply the Z test, Z is basically comparing the between the expected value and observed value. The word for Z is known as relative deviate, how much it is deviated from the expected value. Here the observed value is 90, here the observed value is 49. There could be another observed value, let's say the 75, there can be observed value as a 99, there can be observed value as a or to 24, like this. All these are the observed value. And expected value is a mean that by and large, people are expected to be around 65. So in all this case, expected value is 65. In case of chi-square test, we'll see that how do we compare the observed value and the expected value. Here it is a 65. So if you want to measure distance from the mean, how far that there is a distance, we measure like this, Z is equal to, in this case, 90 minus 65 and divided by standard deviation, which is 10. So the answer is 20, the 25 upon 10, that is equal to 2.5. So we can say that the distance between the expected and observed value is more than 2 standard deviation. So probability that this event is occurring by chance is less than 0.05, or we can say that less than 5%. Why less than 5%? Because 95% will be between the range of 45 to 85. So if they are outside the range, that means the likelihood that they belong to this group is less than 5%. That means it is significantly away or significantly different from the group. So this is how we are using Z test over here. We are finding out the observed value, the mean of the group, and the standard deviation. Now, in this era, if suppose you are given a series of data like this, marks the 45, 67, 60, 78, 98, all these marks, you make a total and divide by the total number and find out a mean. And for standard deviation, you apply a formula. But all those things now computer is doing by itself. So you need not worry if you can't do that. But basically, you so understand that this is how individual comparison with population will be there. Whether the person belongs to the population or not, that is the question. Now, in this case, let's go for chat and let everybody give me one example. Give one example where you can use that test for comparing between individual and population. Before you start, let me give you so many examples. You are working the ward. There are 100 patients. Out of that, most of the patients get discharged between third day to ninth day. But few people get discharged on the within 1 hour. Other patients get discharged after 100 days. That is unusual, right? So you try to write down the population size and the parameter which you want to use, or in case of a sample, you can use the word variable. So, and then say that how you are going to do it. Say Nikhar has written the BMI, but BMI alone is not an example. You say that there are 100 patients or 100 person in a school and I'm measuring their BMI. I want to find out the outliers. How many students are above the average, above the beyond the they are in the more than 2.5%, lesser than 2.5. In other sense, upper 2.5 percentile, lower 2.5 percentile. How many are they? There you need to find out whether they belong to the same group or not as far as BMI is concerned, not rest of the thing is concerned. So write the population size which you're going to take on also the parameter. Two things you should write down where you want to do this. Right? So try to write down where you would like to do this test. Everybody should write down. And if you are not understood, just write down in chat, not understood. But something you need to write in. Yes, population size you have written very good, 50, but where you are going to take it, whether in school or college or in the society like that. So you should be writing like that. Right? So come on, at least under 5 children, MUSC, you are good, but where you will be doing, how many students you are going to take and where? Quick, be quick. Or just, yeah, 200 children in the school, yes, good. And you will find out outliers, right? So any other 2% is written. What is about Priya and Anuganti and so many Venkatesh, etc. Everybody should write down something in the chat because this is the first example. Like now we are going to take a few more examples also. Anyone else? Okay, then you need to write down in the group. So I'm now moving for another example. You want to compare sample with the population. Now remember here you have two examples, sample with population in case of mean and sample with the population in case of the proportion. Now, this the series I'm deleting. Now I'm going for first this example. Let us see this. Suppose I want to compare two therapies. One is the diet therapy, other is physiotherapy. We want to compare. And we want to find out the, in case of this, we want to compare, suppose, diet therapy. And here, and the result we have, the result of diet therapy. Right? And in this case, I have the in diet therapy, I have 1,000 population where I am using the diet therapy. And there's another 1,000 population where I am using physiotherapy. Now, this diet therapy, I want to say that out of 1,000, I want to find out whether they have got the weight loss, how much weight loss they have in 1,000 population. So I have taken a sample of 100 individuals out of 1,000 in diet therapy group. And based on that, in this 100 individuals, the mean weight loss is 2 kg, let's say 2,000 grams. And the standard deviation was you need more clarification. Okay, I will come back to that. Okay. And the standard deviation is, let's say, 200. There's a mean weight loss. Now, remember this. I want to find out with comparison the sample with the population. My population is 1,000. Everybody is with me. Population of a diet therapy group is 1,000. Out of I have taken a sample of 100 individuals. That 100 individuals, their mean weight loss was 2,000 grams with the standard deviation 200. Now I want to find out what would be the mean weight loss in 1,000 population. Based on this, that is my question. So here I need to find out standard error of mean. I repeat, we need to find out standard error of mean. And that standard of mean, how can we find out that? That is usually what we say that SD upon root n. Or you can say the root of the SD square upon n. Both are same. Right? Now, this SD upon root n, that is a very, very interesting how it is derived. That we'll talk at some point of time. Very interesting. But this standard of mean says that if you take, this is a sample of 100. Logically, you can take such hundreds of such samples out of 1,000 by varying one or two things here or there. But for timing, we have this one sample. Based on that, we want to find out the population mean. So population mean belongs to sample mean plus minus 2 standard error. Now in this case, try to find out the standard error. Standard of mean is equal to SD upon root n. SD is 200 and root n is 100. So root of the 100, which is the sample size, that root of the 100 will be 10. So 200 divided by 10 will be 20. Result will be 20. So you can say that standard error of mean equal to 20. So sample mean will be, you can see over here, population for this 1,000 people, the population mean belongs to sample mean was 100, 100 plus minus 20 is the standard error. That means 2 standard means 20 into 2. So the 40 is the plus minus. So the population mean will be, so there are 100. So we have mean loss is 2000 grams plus minus 40 because standard is to 20 plus 40. So you can safely say that mean weight loss of 1000 people will be between 19602 2040. Even just by finding a mean of 100 individuals, you have found out that the mean reduction in those on the diet therapy would be between 19602 to 2040. Now, here I may have a pause for you to ask me a question, and then we'll go back to another example whereby you need to say that whether this sample belongs to population or not. This is an example where we are looking at sample, based on sample, we are finding about the population mean. In another example, we'll find out whether the sample belongs to population or not. Now, any clarification required in this example? You can unmute and ask. Anuganti Ratnachari. So, I repeat, we had 1,000 population. We have taken a sample of 100. The mean weight loss was 2000 grams. Standard was 200. We found out the standard is 20. Based on that, we found that the population mean will be between 19602 to 2040. Now, suppose if someone in the same example, someone says that, no, actually the 100 people when we measured, their mean weight loss was 3 kg, 3,000 grams. Now, if this is a situation, what do you think? Whether this sample of 100 was taken was a random sample or not? I repeat my question. Whether this sample of 100 taken from 1,000 population is random or not if population mean weight loss was 3,000 grams? You in answer me yes or no. My question is, if the 1,000 population mean weight loss was 3,000 grams and very interesting and sample of 100 out of this 100 showing 2,000 gram weight loss with standard deviation of 200 gram. My the question is, do you think this is representative sample of population? You need to answer this. Is the right yes, no, or do not? Write something over here. If you write something over here, then you will understand. Just participate over here. No. Wonderful. Then anyone else? Okay. Not okay. Yes or no? Yes or no? So the answer is no, because how do we calculate that? How we say that it is not? Because you can say that you can see over here. In this case, what do we do? We find out Z. In this case, we find out Z. Z is equal to population mean was 3000 milligram, 3000 gram minus sample mean was 2000 grams, and the standard of mean was 20. So you can say that Z is equal to the 1000 by 20, that means 50. That means the distance of expected value and the observed value in terms of standard error was 50, is very high. So it looks like the sample which was taken was purposive sample, or it was not a random sample. There was some bias which you can find out. So with this Z test and with this standard of mean, we can do two things. You find out the population mean based on a sample, or you can find out whether the sample belongs to the population or not. These are the uses of standard of mean. Once you have understood that, we'll go for standard error of proportion. Now let's take another example. We have the population of let's say 2000 population, and this population we are taking it in the school, and we are asked them whether you had suffered from sickness or not in last 1 year, and say out of this the answer was we took a sample of the let's say 200 people, and we asked the question that whether you have suffered or not. The 150 students said that yes, we had suffered from some kind of illness. 50 students said no, and this is a sample size n. The question is, based on this, we need to find out if 150, that means 75%, we call it as a P, 75% suffered, and Q means 100 minus P. So Q is equal to 100 minus P, that is 25%. Now remember, we are not using absolute value in this case. We are using the percentage in case of proportion. We are now going to find out standard error of proportion. Here we call it as a standard deviation. Here we call it a standard error of mean. Here we are using the word standard error of proportion. Here we are using a standard error of difference between two mean. And here we are going to use standard error of difference between two proportion. Right? So basically, this standard deviation was finding out how far they're different in terms of how many standard deviation away between the mean and the expected, the observed value. In this case, sample mean and a population mean, how far they differ. Here, the sample proportion and population, how far they differ in terms of standard error. Here, between two mean, what is the difference in terms of the standard error? Between two proportion, what is the difference, right, in terms of standard error? All these Z's, they say that the expected value and the observed value, that difference we are looking at. Now, in this case, we want to find out the population proportion out of 2000 children, how many suffered in 1 year period. only based on sample we want to do it. So you can say that population proportion belongs to sample proportion plus minus 2 standard error. Now, in this case, standard error formula will be equivalent to. Now, in this case, in usually what we do for the standard error of mean, we say that root SD square upon n, or we say that SD upon root n. Instead of SD square upon n, we are using SD into SD upon n. Instead of this, we use P into Q. So we say that root P into Q divided by sample size. This is a formula for standard error proportion. You need not remember this formula because automatically computer is giving, but this is to understand that if the n is larger, you'll get a less standard error. If you get a smaller sample size, you'll get more standard error. What is the standard of mean or what is the standard of proportion? All these are basically nothing but one kind of sampling error. If you take a sample and talk about the population based on a sample, naturally you are likely to have some error. I repeat, when you talk about the population based on a sample, you are likely to have some error. And that error is known as sampling error. When you are standardizing it with a particular formula, you label it as a standard error. And that is standard of mean, standard of proportion, standard error of difference between two mean, and standard error of difference between proportion. These are four kinds of standard error. In this case, we are talking right now about standard error of proportion. Now let's see what is the result is equal to root of now 75 into 25 divided n is 200, right? So let us type 275 multiplied by 25 divided by 200. Then we'll take a root. 9.3, and if we take a root of 9.3, it will be somewhere around 3. So let's say 3 is the answer. So standard is 3. Now, when we want to talk about the percentage of in the population where 2000 students are studying, how many students will be ill in a year period? Then we say that 75% plus minus 2 standard. Standard is 3. So 2 into 3 is 6. So the answer would be 69 to 81% of students will be sick throughout the period of 1 year. This is the answer. I make a pause over here if you understood or not. The data given is out of 2,200 sample was taken. Based on that, we were supposed to talk about 2,000 children. How many children fall sick in 1 year duration? In your case, you can say that based on a sample of 40 cells to these patient of 100 cell, the patients, you can talk about 1,000 patients like that. So here we have found out standard error and then talked that in the whole year period out of 2,000 students, 69 to 81% would be sick. We can convert into the numbers and talk about this. So I invite a question on this and then we'll move for the same other use. Any questions so far? Or can you tell me one example showing this? Can you suggest one example where you want to compare the population proportion based on a sample proportion? Uh, you can just talk about some parameter. Let's say a very simple thing participated in Navratri. How many population Bara participated in Navratri? Take a sample and talk about the population. Or you can say that the participation in, yeah, proportion of hypertension in population. But in that, your population would be adult population more than 20 years, something like that. Or you can say that the percent percent of population taking self-medication that you want to find out in a population of, let's say, Surat, like this. So this you can find out by taking a sample. Any question on this? Then we'll be moving further. Okay. So in the same example where we are talking about, actually when we found out this 2,000 students and we took our survey, the actual result was 1,800 students felt ill once upon a time, at least once in a year, and 200 did not. That means this figure shows the 90% is 90% and Q is 10%. Now, whether to find out whether this sample belongs to population or not, whether this sample is bias sample or not, for that, if you want to find out, you need to apply the Z test. And this Z is equal to, you can say that over here, 90% is a population proportion minus sample proportion is 75%, and the standard error of proportion is 3. So now Z is 15 upon 3, so Z is equal to 5. If Z is equal to 5, what is your interpretation? Whether the sample is representative of the 2000 or not? If Z equal to 5, what is your interpretation? Whether the sample of 200 belongs to the same population or not, whether this sample is random sample or is a bias sample. Tell me that. Yes, no, it is not a random sample. It is a bias sample. There is a significant difference between the sample proportion and the population proportion. Right? Because Z5 is beyond 95%. P value is less than 0.05. 0.05. That is less than 5% chances that is a by chance. So there is a significant reason. So whenever you say that when Z is more than 2, probability of having by chance is less than 0.05. That is significantly different. This sample is significantly different. Right? So once you have understood this, right, we'll move further. So these three examples I repeat, then we'll go for this. This is two comparison between two populations far simple. The most complicated is sample with population because here you were talking about based on sample you want to find out population parameter. Based on sample, you want to find out population parameter in this case. And another use was based on sample, you are telling that whether this sample belongs to the population or not. That was the two dual purpose of both this formula. While in this case, when you want to compare these two population, you have only one purpose. Whether these two populations differ significantly or not, that's why this is relatively simple. So in this, we'll go for this example, the comparing two population. Essentially, when we compare two population, we may not compare directly to the two population, but we compare the take a sample of both the population, compare these two samples to find out whether there is a significant difference or not. So we'll take one example. So we want to the same example, the light therapy and other is physiotherapy. And we want to find out weight loss. So mean weight loss, here it was 2000 gram. And with the physiotherapy, the mean weight loss was the 1900, the 1080, right? And then we also found out the standard deviation. The standard deviation was over here, 200. And this physiotherapy, the standard deviation was, let's say, 300. And the sample size in both the group, N1 and 2, sample size was, and let's say both the group we had 100 sample size. Now, in this case, we want to say that the weight loss was significant or not. That we want to find out so that we can then we have this x1 minus x2. What is that? The 2000 minus 1980 that we have, and that is the answer is 20. So difference is 20 gram between these two therapies. Diet therapy and physiotherapy as far as weight loss is concerned, difference is 20 gram. Now, whether this difference of 20 gram is significant or not, for that we want to find out standard error of difference between two mean. And for that, the formula which we are using is, see, if you want to use standard error of mean, what you say, what you take that root of you were taking as the square of SD, and you were dividing by n. That was the formula which we're using. But in this case, this was a formula for the standard error of mean. But when we want to use standard error of difference between two mean, then what we do the same thing, but we take square root of the SD1 square upon N1 plus SD2 square upon N2. That's what we are doing, right? Square root of. So SD1 square, SD1 divided by N1 plus square of SD2 divided by N2 and whole root we were doing. This is how we do the formula. SD1 square upon N1 plus SD2 square upon N2 whole into the root we are taking. Now here the SD1 square, that means 400, 4,000, uh, 40,000. 200 squares is 40,000 divided by N1, that will be 100. So it will be 400 plus we'll have 300 a square, that is a 90,000. 90,000 divided by 100, that is 900. We make a total of it, that is 1300. And if you take a root of 1300, that will give you the standard error of difference between two mean. So root of 1300 you need to take. It will be around, you can say that, uh, 40 to 40, 35 to 35. Roughly it will be the 36. So 36 is the standard error of difference between two mean. So up to two standard, 36 into 2, 72 uh, difference can be allowed by chance. But in this case, what we have, look at this. In case of what is the Z over here, so Z equal to, here the mean is 2,000, another is 980. So difference is 20 gram. And that we divided by 36. That means it is less than 2. It is less than 2. So because Z is less than 2, we say that there is no significant difference between diet therapy and physiotherapy. But suppose in this case, if mean is suppose 1800, right? And if we have the same standard error, for example, 30, it may change, but suppose it is same 36, then 2000 minus 1800 will be somewhere around 200 divided by, suppose that is 36, then Z will be more than 2, and we say that it is significant difference. So this is how we use the Z test over here, and you can have some example over here also, or you can ask some question how we can use this. Anyway, I will give another example over here, and then we'll make the forum open for question answer. Suppose we have a comparison between two therapies. One person is using, let's say, albendazole. Other person using neem extract for one infestation, worm infestation. And in this case, suppose the sample size was same in both the group, 300 over here, and sample size 300. I don't want to put that percentage over here. Here also 300. And the result I got out over here that around result got 250 got the result. And in this case, knee mistake, we got a result 240. Now the question asked to you is whether both effect is same or not, or whether it is different. That is the question. So what you are supposed to do in this case, that you need to find out the percentage over here, and then you try to compare with this formula. In this, standard of proportion will be equal to standard of proportion is equal to root E1 Q1 by N1 plus P2 Q2 by N2. You are not supposed to use this formula. The computer is going to give you directly, but for the sake of understanding, we are doing this. Otherwise, AP Info will give you this directly. This is how we want to find out the standard of difference between two proportion. And in this case, the P1 will be 250 out of 300. So roughly it would be 81, 82%. It will be around 80%. So the difference, the 81 into 19, then 80 into 20 divided by 300, divided by 300, it will be like this. And you will have something like standard over here. And the percentage you will be comparing P1 and Q1, and then you will say whether the difference is significant or not. So this particular example, right, will be taking in the next lecture. But meanwhile, you should try to understand that there are five types of Z, and that finds the difference between two observation and the expectation, whether it is what is the distance, relative David, and that will tell us whether this is significant or not. And all this with AP Info, it is just at the click you will have. For example, when you go for AP Info, the things becomes very, very simple. The next session will be starting with AP Info. Today we have seen these five types of Z test. Once we know the theory, the practical becomes very, very simple. Say in this case, we want to compare those who have the taken a Zelo versus sickness. Is the difference significant or standard of difference between two proportion? It will automatically be applied and p-value will be there. Is a 0.3 and you will say that it is not significant. But the same way, standard of difference in two proportion, in this case, when you go for vanilla and when you go for the illness, right? So it will apply the formula and you can see the p-value less than 0.05 and it is significant. That's the manual one. This is automatic. Automatic is very simple, but if you have understood, that will help us a lot. So I will stop sharing the screen. And now the forum is open for questions. And I expect that all of you will be ready with all five kinds of examples in your situation where you can apply which kind of Z. And that examples you can share in the group. And most of your dissertation will require one or other type of this Z application. So next time what we are going to do, will be using AP info and try to solve these problems. If you keep your data file ready in Excel form, whatever Excel form you will share over here, will be using that Excel for the file to do the analysis with AP info. That will be very interesting because it will be your file. So the I will not be able to do the NS on all the 15 files, but first two or three Excel files which you will be sharing in the group, I will do the NS. You need not share the whole thousands of data. You can sample data 100 or 200, 300 sample data you can share, and then we can talk of the Z test. So now forum is open for the question answer. At least there is no question. You should write down no question. But something, the more you will become active, it will be uh, useful. You can say that how much you have understood, 40%, 30%, right? Something like this. Z score and Z test say the Z score and Z test. Test is a test you are applying. Score means whether it is Z is equal to 2, 3, 4. And based on Z value, you are looking at the probability. I think it is better you have talked about this. Next time we'll be talking, we'll start with the Z table. Based on Z table, how do you find the probability? That will be interesting. Then we'll go for the AP. SPSS and AP info both are easier. Only thing that FE info is a free and SPSS is the license version, and SPSS is giving a much advanced and faster result than the AP info. So I would say that SPSS is better than AP info, but for the beginners, AP info is free, and that's why it is better. If you have a lot of money, then go for SPSS, no problem. Okay, let's put an end to it. And I hope everybody will be ready with the data which you would like to analyze and try to do it yourself. Thank you.